Bun version 1.0 has been released, and bundler only works for React, unfortunately. So I was looking for uh, different configurations so I can find something that works with Solid.js. And the usual thing that they say is Bun creates Solid.js, but this unfortunately uses the white. If you go inside Solid project, and if you look at this configuration, it uses white to bundle the Solid project, because Bun bundler does not support Solid.js. It only supports React, which is kind of sad. So, and I think using white when Bun has a bundler is kind of cheating. So in the past couple of days, I was working on my own configuration, which is currently 500 lines of code just to compile Solid.js. But it's not just to compile Solid.js. It's kind of actually a cool concept. Um, the bundling works kind of different, and I think it's a very cool concept. So here's my config. Um, when you wanna work with Solid.js or React, or I think pretty much anything that uses JSX, you need Babel, because the Bun has a API. If I can find it, bun.build. Yep, bun.build. Bun.build will actually bundles your code, but if you give it only TSX or JSX, it converts all the TSX, all the JSX component inside of it into React JSX. It doesn't do anything else with it, and it's kind of unfortunate. So I had to get creative, so to speak. So the thing that I do, let's ignore up there for now. This is for later. So the thing that I do is kind of make my own directories. Like where is the SRC directory? Where is the destination this distribution? I think directory is, where is the bundle directory, and where is the public directory? Public directory. This is the Chrome extension, by the way. So I need to have a public directory for the manifest and so on. The public directory just gets copied into this directory. That's all we do with that. So yeah, I make my path. I clean the dist and bundle directories, and I create them again. So it's kind of a clean dist and bundle every time that you run the build script. This is how it works. First, it indexes. Let's ignore all these functions for now. If we go a little bit down, we can see, yeah, it's a long config file. So yeah, here, those are our just function definition and variable definition. Here, we start with indexing. The indexing is for indexing the files. We index the files only one time. So like we wanna know what files are in the project. We give our index as an entry point, and we only use the bun.build here for indexing. We don't output anything. So there is you can write plugins with it, but plugins aren't really, how can I say it, aren't really like Bun Bun API is very immature because it's version 1, and it misses like a lot of things. So you can't do like a lot of things with it, but you can do a good amount. here what you return on each, you have a, when you make a plugin, you give it a name and a setup function. The setup can be sync or async, and the setup gives you a plugin builder, and then you can do unload with it. This unload will, every time it finds it founds like a new path or new imports, so to speak. Like here, we importing the header from layout header. Okay, it goes through the unload callback, and you can filter by the, like, what do you wanna um how do you say, what do you wanna do with the path, you know what I mean? And it gives you the path and other things, but those aren't really that important. And you return a content with it, like you return a content uh for that file. So for SAS files, what we do is we add them to a, we have a assets, we have asset type. That asset type describes each asset, where is the directory, where is the ext, where is the path, the base, the name of the file, the hash of it, and so on. And what type is it? Is it a style? Is it an script? And so on. And every asset has a builder function to it. So like you can, if you have an asset, you can call this builder. The builder, what a builder does is that it basically transforms that asset into a usable thing that we can use. Like if it's a SAS, it will transform it into a CSS file. If it's a JavaScript, if it's a Typescript, it will transform it to a JavaScript file, or it's a JSON, it will transform it to JavaScript technically. And that's what we do. We have a PD asset. This PD asset, it exists only for, so we can check, is this asset is new, or is it adding again? Because we have a watching file. So like if a new file if a new file was to add it to our bundle, we can just check, did we index this file before, or is it new? If it's new, we will add it to your watch list, and we will build it. And we have a map here. This map is a number to an asset. I'll talk about that later. And then we have we will index everything. We index our TS6 files, and for TS6 files we have to return the content, so the bundler can understand, kind of, so you can go through the path and extract more imports. We have to, for TS6 and TS files, we have to return a content. And we do the same thing with JSON files and TS files. We basically add them to our files that we are tracking, and we log how much it took. For indexing 7 assets or 7 files, it took 11 milliseconds. Yeah, the building is kind of, or the bundling process is kind of slow, but I don't know what's up with that. Like 11 ms is, I don't know if it's a slow thing or a fast thing, but it's kind of feels slow to me. I don't know. So yeah, the next thing that we do after we index everything, we once build all of them. Like if we index, after indexing, we build all of the assets. Like we go through through all the assets that we collect, and we build, like asset that build. And each of them and each asset have its own builder. Like SAS has a SAS builder. Okay, SAS builder will read the content of the SAS file, and it will use the SAS embedded module. Embedded module is faster than just SAS module. That's why I'm using that. And if it compiles compile the SAS content, compress, make them compress, make the CS output compress, and generate source map files. And the only file system that I'm currently hashing is the SAS. I mean, you can also hash the Typescript or JavaScript files as well, but for now um, I'm only hashing the style files. Because I think hashing it is kind of slow. I'm not sure. I didn't measure the performance. Like my mindset is currently is that if I think hashing it would be faster, but alright, let's move on. So we hash the output and we check the hash. If the old hash is equal to the new hash, so we don't really have to do anything, we can just return. But if it's not, we basically get the old CSS path and we update the asset hash to the new hash. We resolve the new path and we remove the old CSS path with the old CSS map file basically. This would be like in the dist, style, layout, header, for example. And I have to refresh. So yeah, this is the new stuff. So like every time that we generate something else, we delete the old file. So there's not gonna be a lot of them. And yeah, we basically write the CSS output to the this directory. Very, very simple. And this is this is all about the like the everything that you need to do for the CSS file is very straightforward. But for the other ones, for the JSON and TS and TS6 file is a little bit more complicated, so to speak. So what we have to do um, for TS files is that we have to write all of them into a separate directory. I call it here bundle. They don't go straight to the dist. They go to bundle first and then they go to this directory because so what we do with for the like for example for the TS files, okay, we read the content, then we transform the TS files to the JavaScript files with the Bun transpiler. This is the Bun transpiler. It is the same reason that we can't use the Bun builder to output solid to transform solid JS to JavaScript is the same reason that we have to do we have here. Like the transpiler is the one that we have to blame for it. So the transpiler will transform the TS file to JS file very easily. Like there is no problem there. And then what we have, then we give the content file to the another function. It's called update import. The update import, what it does is that it first basically reads all the imports in the file. Like imagine you have this index.js file. The transpiler gives us the information about all the import files in here. Like every import statement that we have in here, the transpiler gives us all of this information. And it gives us and it says what actually we are importing. And here, what we do is pretty straightforward. We get the path, and if it starts with Solidjs, we don't really care. We continue, we move on. If the path starts with ./ that means it's a local path. That means we are importing something from that local directory, so we resolve it like this. We very much want to get the absolute path. Why do we want to get the absolute path? Because if there is a new import, like we are watching the files here, right? If there is a new import, we want to check, do we have this file in our watch list or don't? If we don't, watch the file. Okay, that's why we are doing this. And also, we check for .css files because we don't wanna bundle those in here. Like those are already have been compiled to CSS files, so we don't care about them. We don't care about those files. So pretty much what I have in here is that you shall remove them completely, but for visual sake I'm commenting them out. If you look at these, I'm line 6. I'm commenting the style import statement completely. This is this thing, and then we pretty much return true. Return true means the file is new, so rebundle it basically. If I, for example, come in here and let's just say console.log hi, okay, and then you can just see this asset index.tsx was changed. The build took 10 ms, bundling took 9 ms, and updating the index.html. So what happened here is that here at the end of the file, like after we build everything for the first time, for the initial startup, bootstrap basically, then what we do is we bundle. Then after bundling, we update the HTML. HTML updating is pretty much we write a HTML template to the this index.html. Basically, we write that in, and here we just say this content is for CSS files, because for now you can bundle all the CSS files together, but for now I'm doing um, one SAS file equal one CSS file, so I can keep track of them individually. But you can bundle them all together. That's why. And here I just pretty much look for all the assets, and if their type is a style, I just add a CSS style sheet link for that individual asset. That's that. And we have a index hash. Index hash is the bundled index. Like if you look at this, and I need to do a refresh here. If you look at this, it's a index dot a hash dot js. Like there is a hash in there, so I need to keep track of that hash. If the hash changed, basically we have to update our index.html so the hashes match. You know what I mean? And that's about it. Like very very simple stuff. And the more interesting part, in my opinion, is the watch part. Node.js has a watch API, and so does Bun. Like if you look at the Bun documents, there is a watch mode. Yeah, right there. But the watch mode does not have any API. Like, yeah, there is a flag that you can watch, but the watch mode doesn't have a um. There is zero API for it. Like if I use bun run build.ts and if I add a watch in here, this is not gonna track all of my source files. This is only gonna track the build.ts. Like if I change build.ts and I make this s, for example, we can um add a new line at the end, for example. Then I think this is gonna, but even this is not gonna rebuild because I'm in a while loop. Like that's not even that's not gonna happen. So yeah, the watch flag is pretty useless and there is zero API for it. So Node.js also has a watch file API, like Node.js fs API. If you look at that, Yeah, the FS, FS API has a not the promise one, the other one. It has a watch API, but this watch API sucks. Like it's a very crappy watch API. So I had to get like a little bit creative, and Node.js and Bun both support FFI. Like to be honest, before I didn't know what FFI is. What FFI apparently is that you can write a C program and basically compile it to a shared library and use the function inside of that shared library. So then I'm a C programmer, by the way. I wrote a simple C script that it's a C wrapper for I notify syscalls. The Linux, which I'm using Arch, by the way, the Linux kernel itself give us I notify syscall. I notify syscall is literally a watch file API that you can use. You initialize it and you can close it. You can check it. You can check there is any if there is any new update. Literally, you can read it. If you can't read it, like uh, if the read size is less than 0, which means there is no new content there. Okay, and you can add a file to your watcher, basically, to your iNotify instance, so to speak. And I had to write my own wrapper for it. And pretty much all of this shenanigan at the beginning is my wrapper around iNotify, which I compiled to libwatch.so. And that's what I do. And that's what I get. We loop, we sleep, or this is sleep. I don't think it's even that necessary, but I have it there just for funsy. And we sleep for 200 milliseconds, and we check our iNotify instance, and we give it a pointer to a uint32 array, like technically like two unsigned integer back to back. That's what I think about. And then this give us a very nice API or very nice result technically. It give us like a WD. WD is a like in Linux we have numbers for file handles. Like if you open a file, you get a number back for it. Okay. So this WD is exactly that. Like every time that you add a file to your every time that you add a file, it will give you a number. So that map up there that you WD assets that you see, it maps that watch number to the asset. So like you can very nicely get the asset back, the asset that changed. You can very easily with WD asset.get you can get it back. And if the asset doesn't exist, which should not never exist, which should always exist because you know we should always have that asset there. We basically throw an error and stop the program, basically crash. And this is the interesting part, which I didn't know. So very much, the way that my editor works in here, my new Vim, I use Vim by the way. When I save a file, okay, the new Vim uses a buffer. Like I don't know about other editors, but the way that NeoVim works is that NeoVim has when you change something, it doesn't obviously write it to the original file. It uses a buffer. And when you save that, it will basically move that buffer to the original file. Okay, so like if I have here, let's say that we'll just move like just make a new file, touch 12 for 21, 12 for example. Okay, we have a file called 12. This is the buffer. Okay, and when you save the buffer, it will literally move the buffer to the, like, let's say you change this 12 buffer is for index.html, and it will move the 12 to the index.html. It overwrite it basically. You know what I mean? So when you overwrite something, you are basically removing this and moving this buffer to this address. And when that happens, we get a ignore signal. Like, it changes, but it also ignores it, because when you delete a file, it will automatically ignores that file because you deleted it. You know what I mean? So when when we ignore a file, this is a flag for ignoring. We basically add that asset back. Like, we watch that file again and we add that file to our asset list. That this is for that reason. And here, when the only thing that I check in here, in my wrapper, I check for um, move move cells, like the thing that I just described, and modify. Like, this is the only thing that I check, and modify event doesn't get fired because we don't modify it. With editor doesn't modify. That's what I'm saying. My editor doesn't modify, but it's the same idea there. You know what I mean? And every time that it's changed, like the file at the asset basically changed, we basically build that asset with its own builder, and the update file is basically a boolean. The builder return a boolean to describe, did the asset change or not. If the asset changed, and if the asset requires rebundling, because if you edit a SAS file, the SAS file doesn't require a rebundling. The only thing that requires rebundling is the Typescript files. And if the asset requires rebundling, we basically bundle the asset. And if the bundle also returns a boolean. And if the bundle says that we should update the HTML, then we update the HTML. So, like, if there is no change, we don't have to update the HTML. But updating HTML will take usually less than 1 millisecond, so it's not really a big deal. You can just update the HTML every time. It's not nothing. And yeah, that's my 500 lines of code configuring. Oh, I didn't talk about this. This is the important part. TSX builder. So the TSX files are basically the solid JS files. Okay, like, for TypeScript files like .ts file, those are pretty straightforward. Just a strip of the type and you are good to go. You don't need to do much more. But for the TS files, we basically have to convert this JSX to the solid JS stuff. And if you look at the my bundle is currently not, what do you say? It's not minified, so you can easily see it, but there is also an option to minify it. Here in the bundle directory, we are bundling, we are transforming the index.tsx to index.js. And if you look at this, there is a clear difference in the app function here. And here we have a JSX, and here we have a create component function. That this create component is for it's SolidJS stuff. It's SolidJS stuff that we have to replace basically the JS6 files with this stuff. And for that we use Babel. We import the transform async from Babel core. We preset the Typescript. There's some Babel option here, and yeah, our presets are TS preset that we have from Babel preset Typescript, and we have Solid preset, which is from the Solidjs team, I think. And yeah, we pass the config, and we pretty much instead of using Bun's own transformer that we use, Bun's own transpiler that we use for TS files, we have to use Babel. Unfortunately, the one thing that is missing from Bun's transpiler is JSX preserve, which begged the developers of Bun to make it happen, but they say it's not a priority apparently. JSX preserve basically tells the transpiler, don't touch the JSX. Okay, so if we have if we have this transpiler, if we give it the index.tsx file, it should go through the index.tsx and remove all the typing stuff. Like if I have let's just say, let's add a component type in here. Component. Okay. The transpiler should only remove like typing stuff and typings, and just don't touch the JSX preserver just says don't touch the JSX stuff. That's all. But the Bonds transpiler doesn't have that option. Like the only thing that the transpiler does is transform JSX to React JSX, something like that. If you look at the transpiler here, I actually look at this thing, and there was where was it? Let me search for a JSX file types loader runtime. You have these options, like you can set it to React, and preserve. But I saw this and I thought, okay, it should support it because in the doc set is supported. Then I experimented with it and tested like a bunch of things, and it didn't work. Then I had to go to the Bun's own source code, and I found a comment that says that we don't support JSX preserve, and it's also is here like JSX is not transpiled, preserve is not supported by Bun currently. If you don't support it, why are you putting it in the doc? Like, I don't get it. Like, if you don't support it, just don't put it in the doc. Like, is it so hard not to put something in the doc that you don't support? Anyhow, so if we would have JSX preserve, then we could just transpile the TSX files to JSX files, and then we didn't here we didn't need to use TS presets in Babel, which I think would kind of make it faster because we are using bonds transpiler, but I don't think the speed would be that much. Anyhow, so yeah, we just transform it, simple stuff, and we do our update imports, and then we write it. We write our thing to the bundle that says this, but it's actually will write it into the bundle directory. And then the bundler, like the bundle step. The bundle step is pretty simple. We use bund.build, and then we give it, instead of giving it index.tsx, we give it our index.js inside of our bundle directory. And what one thing that I was experimenting with was like if we have all the content, we don't really need to write them into into files. Like we can just load them from the memory. Why are we writing them into files? And then um pretty much you can't do that. Like you can't load the stuff from memory. Like Bun does not support that. Like I was experimenting with a plugin. So this plugin that I was experimenting with, it would basically, for every unload, I would just return the content from the memory. But the Bun actually doesn't support that. Like it's kind of bummer, but it is what it is. Yeah, the Bun API is not really, like when I was working with it, it's not really amazing. You know what I mean? It's a very immature API. But yeah, overall, 500 lines of code, and here we are. And yeah, this is at the end, instead of letting the one to write the result, I write them myself with the appropriate hash, and then we return the true and false, and that's about it.